Ever wondered what the Earth looked like during its frostiest periods? Imagine a world blanketed in ice where massive glaciers dominate the landscape. This chilly scene is not a fantasy, but a chapter from our planet's past known as an ice age. Over Earth's history, we've had several of these icy epochs, each one a testament to the planet's ever-changing climate. Ice ages are periods of long-term reduction in the Earth's temperature, resulting in the expansion of continental ice sheets and polar ice. Dive in with us as we explore the fascinating world of ice ages. How do we know ice ages really happened? It's all in the geological evidence, a treasure trove of data that reveals the Earth's cold, frosty past. Scientists turn to this evidence, using it as a roadmap through history, guiding us back to times when our planet was swathed in ice. One such clue lies in glacial deposits. These landforms, sculpted by the slow march of ice, are like postcards from the past, whispering tales of a colder time. Imagine a glacier, massive and unyielding, grinding against the Earth. It leaves behind a trail of debris, a breadcrumb trail that leads us straight back to an ice age. But that's not all. Changes in sea levels also bear witness to these glacial periods. As ice caps expanded and contracted, they locked up and released vast volumes of water, causing sea levels to rise and fall dramatically. These geological records serve as frozen timestamps of our planet's chilly past. Did you know that ice ages had a significant impact on prehistoric life? This influence is displayed most starkly in the wave of extinctions that swept across our planet during these icy epochs. Imagine, if you will, a world where mammoths, saber-toothed cats, and giant ground sloths roamed the landscape. These magnificent creatures were adapted for life in the frigid temperatures. However, the same ice ages that created the environments for these species to thrive also set the stage for their demise. As the climate fluctuated, so too did the fortunes of these prehistoric giants. The end of the last ice age, around 10,000 years ago, saw a mass extinction event that wiped out most of these large mammals, marking a significant shift in our planet's biodiversity. So, what causes these ice ages, and the glacial cycles within them? The answer is a combination of factors, each playing a part in this intricate dance of Earth and ice. The primary driver is changes in the Earth's orbit and tilt, known as Milankovitch cycles. These subtle shifts in our planet's position relative to the Sun cause variations in the amount of solar radiation reaching the Earth's surface. When the Earth's tilt is at its least severe, less solar energy reaches the higher latitudes, leading to cooler summers. Over time, this allows snow and ice to accumulate, eventually triggering an ice age. Conversely, when the Earth's tilt is more pronounced, more solar energy reaches these regions, leading to warmer summers. This increased warmth triggers the melting of ice, marking the end of an ice age. Additionally, other factors such as the distribution of land and sea, atmospheric composition, and volcanic activity also influence these glacial cycles. For example, higher levels of greenhouse gases in the atmosphere can trap more heat, potentially offsetting the cooling effect of an ice age. The ebb and flow of these glacial periods dramatically reshaped life on Earth. From the rise and fall of prehistoric megafauna to the development of modern ecosystems, the legacy of these ice ages is still evident today. Glaciers tell a chilling tale of the Earth's past. These icy behemoths, remnants of past ice ages, have shaped the world in ways both subtle and dramatic. Let's delve into the stories of some of these iconic glaciers. First, we have the Laurentide ice sheet, a massive glacier that once blanketed much of North America. Imagine a sheet of ice, so thick and expansive, it stretched from the Atlantic to the Pacific, from the Arctic down to the modern United States Midwest. Its melting reshaped the continent, carving out the Great Lakes and sculpting the northern plains. Across the Atlantic, the Fennoscandian ice sheet held a similar icy dominion over northern Europe. This glacier's retreat left behind a landscape dotted with lakes and fjords, particularly in modern-day Norway, Sweden, and Finland. The Fennoscandian ice sheet's legacy can still be seen in the stunning natural beauty of Scandinavia. In the southern hemisphere, the Patagonian ice sheet left an indelible mark on South America. As it receded, it carved the dramatic landscapes of Patagonia and left behind the stunning fjords of southern Chile. But as these icy giants held sway, humans found ways to adapt and survive in these harsh environments. Our ancestors developed new technologies and strategies to cope with the cold. They crafted clothes from animal skins, built shelters from ice and snow, and discovered new ways to hunt the Ice Age megafauna. These adaptations weren't just about survival, they were about innovation in the face of adversity. And just as our ancestors adapted to the Ice Age, so too must we adapt to our changing world today. As we face the challenges of climate change, we can look to our ancestors for inspiration. They showed us that humans are resilient, capable of facing down even the harshest of environments and coming out stronger on the other side. In the end, the story of glaciers and human adaptation is a story of resilience and innovation. It's a story that's etched into the very earth itself, preserved in the landscapes shaped by these icy behemoths. Our ancestors proved their resilience in the face of these icy challenges, and as we face our own challenges today, we can take heart in their legacy of adaptation and survival. Imagine living during the Earth's most recent ice age. A time when glaciers reigned supreme, covering vast expanses of the planet. This chilling period, known as the last glacial maximum, occurred about 20,000 years ago. During this time, ice sheets extended as far as New York City, and sea levels were dramatically lower than they are today. The last glacial maximum was a time of immense cold, with global temperatures averaging about 5 to 10 degrees Celsius lower than present day. This massive ice age was driven by a combination of factors, including changes in the Earth's orbit and the amount of solar radiation reaching the planet. As the climate cooled, glaciers expanded, locking up water and causing sea levels to drop. But as these glaciers began to melt around 19,000 years ago, a warming trend began that eventually led to the climate we know today. This shift from ice age to warm period wasn't a smooth ride though. It was punctuated by sudden, dramatic changes in temperature and precipitation, giving us a window into the Earth's climate system and its sensitivity to change. Which brings us to the topic of climate change. The lessons from the last glacial maximum and other ice ages can inform our understanding of what's happening today. Ice cores drilled from ancient glaciers reveal the Earth's past climate, including the levels of greenhouse gases in the atmosphere. We've learned, for instance, that increases in carbon dioxide levels have historically been linked to global warming. Today, the level of carbon dioxide in our atmosphere is higher than at any point in the last 800,000 years, largely due to human activity. This is causing our planet to warm at an unprecedented rate, with potentially catastrophic consequences. Yet, by studying past ice ages, scientists are gaining invaluable insights into how our climate might respond to this rapid warming. They're learning about feedback mechanisms, tipping points, and the potential for abrupt changes, all critical pieces of the puzzle as we navigate our planet's future. As we face our own climate challenges, these icy epochs offer invaluable insights. Our past, it seems, may hold the keys to our future. Ice ages had a significant impact on our planet's water. Indeed, the ebb and flow of these colossal ice sheets played a vital role in shaping our sea levels. Picture vast glaciers, miles thick, covering large parts of the globe. As these icy giants grew, they drew water from the oceans, causing sea levels to drop dramatically. Imagine during the peak of the last ice age, sea levels were around 400 feet lower than today. Land bridges appeared, connecting continents and opening new migration routes for early humans and wildlife. As the climate warmed and the ice began to melt, the sea levels rose again, reshaping coastlines and submerging these land bridges. These fluctuations in sea levels were not mere geological footnotes, they were crucial chapters in the story of life on Earth. Understanding these ancient cycles helps us predict future changes, especially in the face of modern climate change. These ancient ice caps continue to shape our world from its oceans to its climate. Ice ages may seem like frozen chapters in Earth's history, but their effects still linger. These glacial periods have left indelible marks on our planet, from the geological evidence that paints a vivid picture of Earth's icy past, to the extinctions that echo the brutal struggle for survival during these frigid epochs. Let's not forget the glacial cycles, the ebb and flow of Earth's icy mantle, driven by forces both celestial and terrestrial. These cycles are the heartbeat of our planet's climatic history, a rhythm that has dictated the rise and fall of species, including our own. We've explored the iconic glaciers, relics of past ice ages that continue to shape our landscapes, and learned about the incredible adaptability of humans, who not only survived but thrived in these challenging environments. We've delved into the last glacial maximum, Earth's most recent ice age, and a period that offers precious insights into our planet's climatic mechanisms. We've also seen how ice ages have impacted sea levels, a relationship that holds critical implications for our warming world. And finally, we've drawn comparisons and contrasts between the climate of the Ice Age and the modern climate change we're experiencing, highlighting the importance of historical climatic patterns in informing our understanding of current trends. As we look to the future, we carry the lessons of these icy epochs with us, reminders of our planet's extraordinary past and guides for its uncertain future.